Ohio Minasan. Let's start our lecture 5 summary, which is about Kirchhoff's voltage law, and we'll see about parallel and series wale resistors. So first of all, we have Kirchhoff's voltage law, KVL. We have already seen what it does. It is just if we go in a loop and take the summation of all the voltages as we go and come to the same point, it would result into zero. So that's KVL for you in summary. And then let's take our first example, example one. Here we are given a circuit. This is 2 ohms. This is 20 volts. This is here it's 2 ohms. Here it's 1 ohm, 3 ohm, 20 volts, 40 volts. This is 2 ohms. So in this circuit, we are needed to find the current in each wire. So if we assume current to be flowing from here to here and here to here, we'll take it as I1, this side as I1, I1, here I1, here, and then from here I2, I2, here I1 plus I2. They both will meet here, and according to KCL, it will go from here to here as I1 plus I2. The resistance here was 5 ohms. So now, and again, this would be I2, this would be I1. So we'll first apply KVL here and then KVL here. Stop. We'll go from here 2 ohms as we are going in the direction of electricity. The potential will decrease when we go from in through a resistor along with the current. So that would be minus 2 I1, then plus 20. Here it would be minus 2 I1 minus 1 I1, and then from here to here it's minus 40. Is it? Yeah, minus 40. Then it would be minus 5 times I1 plus I2. It would be equal to 0. This is our first equation. Let's simplify it. We'll be having minus 5i, 5, 6, 7, 8, 9, minus 9i1. Then we have minus 5i2. Then we have minus 20 equal to 0. That would be, we just give up all the minus signs into plus signs. This is our equation 1. And then we have again from here to here it would be minus 2i2 plus 20 minus 3i2, then minus 40, then minus 5i1 plus I2 to 0. That would be 3, 4, 5, 5 to 10 minus 10i2, then minus 5i1 minus 40, that would be minus 20 equal to 0. Is plus plus. Now what can we have common? We can just equate it. uh, Both are equal to 0. Then what would get cancelled? 9i1 plus 5i2 plus 20 equal to 10i2, 10i2 plus 5i1 plus 20. Now this will be 4i1, and this would be minus 5i2. Cancel up into 0. Okay, bad idea. We just have to eliminate it. Means we have. So yeah, 9 fives are multiplied by 5, multiply it by better. We just eliminate I2 plus into 2. So 10i2 plus 18i1 plus 40 equal to 0. And 10i2 plus 5i1 plus 20 equal to 0. Subtract. This would get cancelled. 13i1 plus 20 equal to 0. So I1 equals to minus 20 by 13. I presume. Yes. Then I2 would be 5 times 100 by 13 plus 13 to the 26. Then I2 equal to minus of this. And thus that would be 360 by 13 minus 360 by 13. This gets cancelled. Answers are here. So we have assumed the current to be in the wrong direction. That's why it's minus here. So instead of current coming like this, it would flow out like. We have another example that's similar to this. So it would be good if we look at that. But we have another example that is a bit different from this one. So example 3. Here we have to find current in each wire and also find potential difference between 2 points. This is 20 volts. This is 3 ohms. This is 2 ohms. This is 1 ohm. This is 4 ohms. This is 30 volts. This is 10 ohms. This is 2 ohms. And this is 3 ohms. This would be 2 ohms and 10 ohms. So if we assume uh, current in this wire, this circuit, part of circuit to be I1, here I1, here I1, here I1, here I1, here I1. If we assume it to be coming from here itself, and then here if we assume it to be I2, it will go all the way around and come back as I2. Now let's apply KCL here and KCL here and find out the current in each wire. Here no current would pass, and also this is X, this is Y. We need to find the potential difference between these 2 points. So now let's find out. KCL in first one would be 20 minus 3i1 minus 2i1 minus i1 minus 4i1 equals 0. So that would be 10 I1 equals to 2 ampere. This is I1, and for I2 it would be uh, 30 minus, I think we forgot one. No, we didn't forget anything. It is minus 2 I2 minus 10 I2 minus 3 I2 equal to 0. That is, this is also 2 ampere. Now we have to find potential difference between these 2 points. So I'll assume y point to be having potential 0 because we don't care about the absolute value of it. We only care about the difference between the potentials. So we can assume any number here and we can go through and find out x point. And then the difference would be the same. So if we go y to be 0, if we go up here, we're going through I2. So it would be I2 was 2 ampere, 3 ampere. So 2 ampere into 2, this would be minus 4 volts. And if we go from here to here, as no current passes through uh, this part of the circuit, this wire, then we'll also have minus 4 here. Not minus 4, this part will be minus 4. And then if we jump over from this, we'll get a potential hike of 10. So that would be 10 plus minus 4 equals to 6 volts. And we are going opposite the I1 current. So it would be plus I1 into 1 ohms. I1 is 2, so 2 volts hike. So 6 plus 2 is 8 volts. So X minus Y would be 8 volts. So Vx minus y equal to Vx minus Vi equals to Vy equals to 8 volts. Then now we go to equivalent resistance. We have two types of equivalent resistances. One is in uh, parallel and another one is in series. So in parallel, in series, first of all, we have to know what equivalent resistance is. So it would be the resistance applied by all the resistors inside the circuit, uh, which would exert the same, dissipate same amount of energy, same amount of power as not all the resistors together would do, and it would also apply have the same current passing through it equally. So let's read the definition. Equivalent resistance is the resistance which replaces entire circuit and extract same amount of current from the battery as uh, this R equivalent will dissipate same power as dissipated by entire circuit. So we'll see in series combination we have the formula we need to remember is R equivalent equals to R1 plus R2 and so on. And we need to know that same amount of current passes through it, and current through it is same. And another thing is they are connected end to end. Even if we are connected end to end, if current would be divided, then it would not be considered as series. So we'll see our first example. And also we need to remember about the power. So power would be here, power would be I square R equivalent. So I square sum of all the resistances. That's pretty much it. E equivalent equals to I square R equivalent. We can also find out using V square by R, but it's much preferable to use this one because we can directly use R equivalent formula of the series here. And then another relation we need to remember here is that power dissipated would be directly proportional to R. So if we ever have a question which asks about how much if a bulb is radiating this much energy, which light bulb would be much brighter, then the one which has more resistance would be uh, it would be much brighter because it is dissipating higher amount of energy. Then we have example. We'll just do one of the example because second example is the exact same of first one. So first one is in such questions first we find R equivalent and then current, and if we want to find power that would also be easy using I square R. You can also use V square by R here after finding out the resist R equivalent, and if we are given the voltage of the whole circuit, here it is 220 volts, and then this 2 ohms, 3 ohms, and 6 ohms. So if we sum it, the R equivalent would be 6 plus 3 plus 2, 9, 10, 11, 11 ohms. And then current would be, the whole current would be 220 by 11. V by R formula, so this would be 20 ampere. And then we need to find the uh, potential difference for each one of them, V1, V2, and V3. Our simplest method would be using Ohm's law and finding out V equals to IR. So I, we have already found out 20 into R, the 20 into R of each one of them to find out the potential difference across them. So V1 here equals to 22 of 40 volts, V2 equals to 23 so 60 volts, and V3 equals to 6 into 26 to the 12 120 volts. So if we make uh, if we add all these up, we get the same amount of potential difference. 6, 10, 10, 22, 220 as a whole. Now we need to find the power. Power equals to I square R. Or we can also use V square by R. This is I square R is I is given as 20, so 20 square is 400 into the R equivalent here is 11, so 4400 watts of power is dissipated. Total power dissipated. Power by each one of them is also been asked, so P1 equals to I square R also we can do. So we have gotten IV, so IR we have gotten, we can multiply. We have another formula for power which is V into I, so that would be V1 into I. So 4 to the 800 watts. V2 equals to V2 into I, so 60 into 20, so 1200 watts. V3 equals to V3 into I equals to 120 into 20 equals to 24,000 watts. Here we can see this relation working here. So higher the amount of its resistance, the higher energy, the power it dissipates. Now we have parallel combination resistance, resistors and their equivalent resistance. power. So this was for series combo. Now we are looking for parallel combo, parallel resistors. So the formula we use here is for R equivalent, it is summation of 1 by Ri, which can also be expressed in the terms of conductance. So S equivalence equals to summation of S. We write it here for parallel. It is S equivalence equals to summation of Si, and 1 by R equivalent equal to summation of 1 by Ri. Now, in our circuit, we have, you can find out here we have an interesting relation for current through a wire. If I current flows from here to here through a parallel combo circuit, the general I1, I2, I3, we can find out each one of them just by, this is R1, R2, and R3. So we can find out each one of those current not by V by R. If we are not given V, then we can find out using R equivalent and this total current. So that will be, first we'll find out the R equivalent. The relation generally is I1 is to I2 is to I3 equals to R1 is to R2 is 1 by R1, sorry, 1 by R1 is to 1 by R2 is to 1 by R3. That generally means that more current will pass through the path where there is less resistance. So, and I equals to I1 plus I2 plus I3. So, a relation is I1 equals to R equivalent by R1 into I, and I2 equals to R equivalent by R2 into I3 equals to R equivalent by R3 into I. So, here it would mean I x equals to R equivalent by Rx into I. Now let's move on to examples. We have only two examples. First one example, that is I equals to, here we are given a circuit with I coming as 30 amperes, and then I1, I2, I3 we have to find out, and resistances are, this is 6 ohms, this is 12 ohms, and this is 24 ohms. So R equivalent is, so the R equivalent would be 1 by 24 plus 1 by 12 plus 1 by 6. So that would be 24 by, uh, R equivalent here is 24 by 7 ohms. Now current we can find out by R equivalent 24 by 7 divided by R1 into 30 would be 30 by 7 ampere. I2 would be 24 by 7 into 12 into 30 equals to 60 by 7 amperes. I3 equals to 24 by 7 into 6 into 30 equals 120 by 7 amperes. That's all we needed to find out. Let's move on to the next topic. That is, we have only two such wires in parallel. It is much easier to find out because R equivalent here would be, if we flip that over and take the LCM, it would be R1 R2 by R1 plus R2. This is I coming here. So I1 would be I1 would be, if we divide from the earlier formula, it would be R equivalent by R1 into I. That would mean R1 and R1 would get cancelled. So R2 by R1 plus RT into I1 in similar into I. So in similar fashion, it would be R1 by R1 plus R2 into I. So for two res parallels, it would be I1 equals to R2 by R1 plus R2 into I. And an example of this, oh, shouldn't. Here, R1 is given 5 ohms, R2 is given 3 ohms, 3 ohms, 15 ohms, and I is given as 12 amperes. So I1 would be 15 by 20 into 12. Ah, so 20, 4 to that, 4 to that 12, so 9 ampere. And I2 would be 5 by 20 into 12. This is 3 ampere. Here, as resistance is higher, I2 is lower, resistance is low, I is high. That's all. Thank you.